This is the lecture for Lab 1, Introduction to Lab. And in this lab, we will be going over the metric system and also introducing you to different types of equipment that we will be using during the semester. During the semester, as you perform the different types of lab exercises, you will be generating scientific information. And the form that information will be in will be called data. So data is how we refer to all the different measurements that you will be taking for all the experiments. You will be measuring changes in weight, changes in height, and other types of measurements. And that is what makes up scientific information. When generating scientific data, we use the metric system. And the metric system is a little bit different than the normal system of measurement that we use in everyday life. In the metric system, meter is the unit for length, gram is the unit for mass, which is basically like weight, liter is the unit for volume, and Celsius is the unit for temperature. So all the information, all the data that you are generating in class during the semester needs to be recorded using the metric system. The metric system is a very logical system of measurement that is based on using different prefixes for the different size units. This is a scale that gives you the different prefixes and tells you how they relate to the base word. So here is where you would put the base word, the base unit, like meter. Meter, remember, is the measurement for length. And then by using the different prefixes, that tells you how big the different units are. So a meter is the base, and a meter, if you remember, is about the size of a yard, length of a yard. A decameter is 10 meters. So 10 to the 1 is 10. A hectometer is 100 meters. So 10 to the 2, 10 squared is 100. The one measurement you are probably most familiar with is the kilometer or the kilometer. Kilo means 1,000, so that is 1,000 meters. And a kilometer is about the length of a mile. So that is increasing in size. So the unit increases that way. If you're decreasing in size, you would move to the right. And a decimeter is 1/10 of a meter. A centimeter is 1/100th of a meter. And a millimeter is 1/1000th of a meter. This is the same information with the prefix scale for metric measurement, just presented in a slightly different form. So here at this line, this dark line, this is the baseline. So instead of meters, now we'll talk about grams. Grams. And so that's your basic gram. And again, a gram is a measurement for weight. So if you are increasing in size, unit size, you have a decagram. There are 10 grams in 1 decagram. Hecto means 100. So a hectogram has 100 grams in 1 hectogram. And a kilogram is 1,000 grams in 1 kilogram. And then decreasing in size, you have decigram is 1/10 of a gram, centigram is 1/100th of a gram, and a milligram is 1/1000th of a gram. So again, this is the same information that you saw on the previous slide, just in a slightly different form. In lab, when we're doing the different experiments, we tend to work with the same measurements over and over. So some of the most common conversion factors that you probably need to know are listed here. So 10 decimeters are found in 1 meter, 100 centimeters in 1 meter. So centimeters, kind of think of those as inches. They're a little bit smaller than an inch. 1,000 millimeters in 1 meter, and then there are 10,000 micrometers in 1 meter. And then moving up in size, again, 1 kilometer is 1,000 meters. So these are just some of the common prefixes that we will be using frequently in lab. And again, the meter can be converted to grams or liters. So you can just change the root of the word, 10 deciliters in 1 liter. In the lab, you will have several unit conversion problems that you will have to do. A unit conversion is where you take a measurement that was measured in one particular unit and convert it into a second one. So for example, you could take something that was measured in ounces and convert it to liters, or something that was measured in centimeters and convert it to meters. The easiest and most accurate way to perform a unit conversion is to use algebra, a very simple type of algebra. And for this, you will need a conversion factor. And the conversion factor is what correlates the two units together to each other. And also, you will be converting the numbers into fractions that will enable you to cancel out the units. So, for example, a simple unit conversion problem could be 4 yards equals how many feet? Now you probably can do this in your head without thinking too hard because you're used to working in yards and feet. But I just want to go through how you would do this unit conversion using algebra. So the first number that you have is yards. So you have 4 yards. So you will convert that to a fraction. So 4 is also 4 over 1. So that's a fraction. Then the unit is yards, so yards, YD, goes after the 4. Now you're going to take your original number and multiply it by a conversion factor. So the conversion factor is also going to be a fraction, and what you're going to want to do is to cancel out yards. So that means for your conversion factor, yards has to be in the denominator. And for this, you are correlating yards to feet. So yards will be on the bottom, feet will be on the top, and now you need the numbers that correlate the two measurements. Often it is easiest to take the larger one, which is yards. A yard is longer than a foot, so in 1 yard you have 3 feet. And that is the conversion factor if you didn't know it before. There are 3 feet in 1 yard. Once you have your original number, you multiply it by the conversion factor, then you can come up with the answer. So if you remember from fractions, if you have something in the numerator and something in the denominator, you can cross them out. So yards will be crossed out, and then you just multiply across. So 4 times 3 is 12, and that will be feet. And 1 times 1 is 1. And so if you convert this to a whole number, it will be 12 feet. I'll give you another example of a unit conversion, and again, use the algebra and first convert all the numbers to fractions, and you'll be using a conversion factor. So for this problem, 65 inches equals how many feet? Now this you may not be able to do quickly in your head, but it is easy if, again, use the fraction system. So first, 65 inches, convert it into a fraction, 65 inches over 1, and you're going to multiply by a conversion factor. So you're going to want to cross out the inches, so inches have to be in the denominator here. Your conversion factor is correlating inches and feet, so feet will be in the numerator. And you should probably know that a foot is larger than an inch. So again, usually take the larger unit of measurement, make that 1. And inches, there are 12 inches in 1 foot. So now you have it set up, your original number, the conversion factor. So now all you have to do is work through that equation, cross off inches because you have inches in the numerator and the denominator. Then you take 65 times 1, so 65 times 1 is 65, that'll be feet. And then 1 times 12 is 12. and then you use a calculator to divide 65 by 12, and you get 5.42 feet. That's a decimal point there. Oop. The previous examples of unit conversions were in English units, which we use in everyday life in the United States. In science, we are only going to be using metric measurements, so metric conversions are something you may not be quite as familiar with. But the overall process is the same: to convert the units into fractions and use a conversion factor. So one example would be to take 250 grams and figure out how many kilograms that would be. So again, the process is the same. Start out with 250 grams, turn it into a fraction over 1, and you're going to multiply that by a conversion factor. So remember, you're going to want to cross out the grams, so therefore grams needs to be in the denominator in the conversion factor. You're going from grams to kilograms, so kilogram will have to be in the numerator. Now, figuring out the relationship may be a little bit harder for you compared to the English units, but that's where you use these prefixes. So you can use either of the two scales that I gave you in the PowerPoint. So for this one, I'm just using the first one I gave you. Remember, the basic unit here would be grams, and then you look at the prefix, kilo. There are 1,000 grams in 1 kilogram. So you look at the largest unit, kilogram is larger. Remember, it increases as it goes this way. So in 1 kilogram, there are 1,000 grams. So then you go through your conversion. You are crossing out the grams. So you will have 250 kilograms. 250 times 1 is 250. And then in the denominator, 1 times 1,000. 1,000, so 250 kilograms divided by 1,000 equals 0.25 kilograms. So 250 grams equals 0.250 kilograms. Here's another example of a metric to metric conversion. So in this example, you have 5 kilometers and you want to know how many centimeters that is. So again, converting everything to fractions and using conversion factors. So 5 kilometers would be 5 kilometers over 1. And then you multiply that by a conversion factor. So for your conversion factor, kilometer is going to be in the denominator so that you can cross it off. And then for the conversion factor, you can try to figure out how kilometers relates to centimeters, but that can be kind of confusing. Or what you can do is use that base word or that base unit, so meters. I find that that is usually easier. So which unit is larger? Kilometer is larger. So in 1 kilometer, there are 1,000 meters. So when you run through this, you're going to cross out kilometer, but you're going to be left with meters, and you need to get to centimeters. So you can actually multiply by a second conversion factor with meters in the denominator so that you can cross them out, and centimeters in the numerator. So with meters, remember meter is your basic unit. Centimeters, there are 100 centimeters in 1 meter. So a meter is larger, and there are 100 centimeters in 1 meter. So now you're going from kilometers, you're going to end up with centimeters, so all you have to do is run through the numbers. Kilometers will be crossed out, meters will be crossed out, you'll be left with centimeters. So now you have 5 times 1,000 times 100, which will equal 500,000 centimeters. And 1 times 1 times 1, all over 1. So your answer is 500,000 centimeters are in 5 kilometers. Also in the lab, you will be doing English to metric conversions. So this is using English measurements and converting them to metric measurements. And again, the easiest way to do this is using algebra and using a conversion factor. So for an example, 2 meters equals how many yards? And the conversion factors you can find in the lab on page 2. And in this case, the conversion factor that you need to know is that 1 yard equals 0.91 meters. So to perform this, it's the same process, 2 meters over 1. You multiply by a conversion factor, and meters will be on the bottom, yards on the top, so that you can cross off your meters. And the conversion factor here tells you the relationship, 1 yard equals 0.91 meters. So you run through this, again, cross out the meters. 2 times 1 is 2 yards, and then 1 times 0.91 equals 0.91. And when you use the calculator and figure out what this is, it ends up being 2.2 yards. So 2 meters equals 2.2 yards. The last example I want to give you is an English to metric conversion. And for this problem, it is 2 liters equals how many ounces? And the conversion factor that is given to you on page 2 in your lab is 1 ounce equals 30 milliliters. So the first thing you need to notice is that the conversion factor is in milliliters, but the question is asking you about 2 liters. So you're going to have to do 2 conversions. The first conversion is to convert liters into milliliters, and then convert that milliliters into ounces. So to do that, you start out with your 2 liters, put it in fraction form, multiply it by a conversion factor, liters in the denominator, milliliters in the numerator. So here you will have liters, your unit, and you're converting to milliliters, which is a smaller unit. So the larger unit is the liter. There are 1,000 milliliters in 1 liter, so 1,000 milliliters in 1 liter. And that will get rid of your liter, so the unit will be in milliliters, but now you want to go to ounces. So you're going to have to multiply by a second conversion factor. Milliliters will be in the denominator, ounces will be in the numerator, and your conversion factor tells you that in 1 ounce there are 30 milliliters. So then all you have to do is run through the equation. So again, liters is going to be crossed out, milliliters will also be crossed out, and you will be left with ounces. So 2 times 1,000 times 1 is 2,000, and it will be ounces. Then 1 times 30 will be 30. So then you take your 2,000 divided by 30, and you will end up with 66.7 ounces. Temperature conversions are a little bit different than the other types of conversions. For this, you are using formulas. So for example, in the first one, if you have a temperature in Fahrenheit, then you can use this formula to find out what that temperature is in Celsius, which is the metric measurement. So for example, let's say you want to know what body temperature is in Celsius, and maybe you already know that in Fahrenheit, normal body temperature is 98.6 degrees Fahrenheit. So to do that, you would just take this number and plug it into this formula. So you'd take 98.6 degrees Fahrenheit, subtract 32. Once you find that number, you would then multiply that number by 5, and then divide that number by 9. And when you plug that into a calculator, you will find out that 98.6 degrees Fahrenheit is actually 37 degrees in Celsius. The other example is that you have a temperature in Celsius and you want to find out what that temperature is in Fahrenheit. And so then the equation is a little bit different. let's say 100 degrees Celsius. You want to know what that is in Fahrenheit. And that's actually the temperature that water boils. So what you would do is take your 100 and you would multiply that by 9 and then divide by 5. Once you have that number, then you would add 32. And when you plug that into the calculator, what you end up with is that 100 degrees Celsius is equal to 212 degrees Fahrenheit. Also, as part of the lab, you will be becoming familiar with different types of lab equipment that we find in the laboratory. First thing is an incubator. This is an example of what an incubator looks like. You'll look around the room and find that. You will also look for a hot water bath. That's what a hot water bath looks like. And then also the freezer. And a freezer, of course, it's the top part of the refrigerator in the room. And as you go through and look at these different pieces of equipment, you'll have to measure the temperature and do a conversion factor. So using those previous algebraic equations. The last part of the lab, you will be using some equipment to actually take measurements. The first piece of equipment you will use is a balance, and a balance is basically a scale where you will measure the mass or the weight of different objects. Then you will use a beaker. This is what we call a beaker, which is used to hold liquids, and it has a scale on here in milliliters that you can get a general estimate of how much liquid you have. You also will be using a graduated cylinder. This is the graduated cylinder. Again, it is used to measure liquids, and you have the scale in milliliters on the side. And the last thing you use to measure liquids are a pipette. So this is a pipette, again, used to measure liquids, and this is the pipette pump that you put on the end of the pipette to draw up the liquid into the pipette.